Hello, I'm Robert Nduhura.
Robert,
Angel Twinamatsiko.
yeah, we are here for our group. We are presenting our LLM language model, and we are going to start by sharing our work and give a detailed explanation of how we came up with the model and how it performs different tasks.
Again, I'm Robert Nduhura. I'm going to present to you a virtual assistant, Tommy the mathematician. And in this project, we developed a virtual assistant designed to teach elementary mathematics in a playful and engaging way to elementary learning students. This assistant aims to make learning fun for children aged 6 to 10 by blending educational content with game-like interaction and storytelling. It was implemented using an LLM, a large language model, in a playground environment by applying techniques like prompt engineering and iterative testing to refine the responses. Our domain here is education, and the assistant is tailored for early childhood education with focus on basic mathematics. With basic mathematics here, we mean addition, subtraction, multiplication, and division. The use case is a mathematics tutor for elementary students, and the purpose is to teach foundational math concepts such as addition, subtraction, multiplication, and division, which is the basic mathematics for elementary learners. The features are engaging math challenges, story-based learning, a cheerful and encouraging tone to build confidence in young learners. The mission is to make math fun, approachable for the mission is to make math fun and approachable for kids by combining playfulness with effective teaching strategies. Thank you.
Yes, Robert. So my section, I'm going to talk about how we implemented the model. So I will start by first things first. The name of our model is Tommy the mathematician. The personality which we gave it a cheerful, energetic, and patient personality, because when you're dealing with children, you have to be cheerful and energetic to the children such that they can get the concepts you're trying to pass out. And again, it gives out encouraging answers. That is to say, if it gives out an answer, it goes ahead and gives out an explanation of how it got the answer and the logic behind the answer. The target audience, as already said, it's between children aged between 6 and 10. Then tone of the voice, it's friendly, simple, and enthusiastic. So our implementation approach, we used three techniques. One is prompt engineering, another one is testing scenarios and security considerations. For prompt engineering, these are the prompts which are given to it and the corresponding answers it gives to the prompts. That is to say, it gives out, if it's asked like, who are you, it's going to give the child a comprehensive answer of like, it's a mathematician, does this and this in this way and this. And how did we come about this? We did this through OpenWeb UI, where we got our image. And after getting the image, what we did was we got our image and hosted it locally on our machine using Docker, and we were running it using Docker, but we later got into a problem where Docker was running very slow. So one of our colleagues opted to offer a playground, which is called Master Playground, on a hosted server where we were implementing our models. So when we go through the step-by-step how we created our model, when you go to OpenWeb UI, we are going to do what? We are going to have a section where there will be like, you create your model. So you come here on models, then there's an option of creating a model. So let's say our model was called Tommy, but we can give it another name. Let's say it's Tom with an H at the end. Then the model ID comes like it's assigned automatically. Then the base model we can use Llama 3, which is the one we're using. Then when we go to the description of the model, we just say the model does simple math, and basic calculations to teach the children about simple mathematics and engaging mathematics. Let's say the model does math. That's a simple description. Then when we come to system prompts, as I already said, these are the prompts which we give it, and it's like what it's supposed to give to somebody who prompts it to do something. Let's say one of our prompts, let me take these prompts which we had used previously and just insert them. When I copy this and insert it the other side, we are going to already have assigned our model system prompts. So when we come here, we are prompt suggestions. It's like you're giving somebody a clue of what they are supposed to be doing. Let's say like, hello, how may I help you today? Hello, do you have new calculations today? Those are the prompt suggestions. So let's say, hello, do you have calculations today? Then for the vision, this will require us a lot of time. Then the tags, a model that for education like this one of ours, we are going to choose a tag which is we are going to choose education, because basically we are talking about math from class, and it's basically education. When I save and create, it's going to create a new instance of the model. So how are we going to host it the other side? The other side, at first we're using Docker, where we're running an image of the large language model, but since it was taking a lot of time to host, we opted to use this master playground, which was a bit faster and it was online. So when I come here and pick this URL and copy it and take it this side, it's taking a lot of time to create. I don't know why, but when I come here, it's going to give me a prompt of where I should put the URL where we are going to host our model. Let's say if it's the local host, if we are hosting it locally on our machine, let's say we are virtualizing our machine and hosting it through Docker, we are going to put our local-host address, which is the localhost /3000 / the port which it's running on. But since we are using an online server, which is a bit faster than a local machine, we are going to opt to host it online. But my friend can pick up from here. Maybe after it has started, we shall come back to it.
Well, my name is Angel Tuinamatko, and I will take you through the testing scenario. We have the testing and results scenario. We used 3 test scenarios. One, that is the happy flow scenario, the handling mistake scenario, then the jailbreaking attempt. The first happy flow scenario, this is whereby assuming a child is doing the interaction with the virtual agent smoothly and without any error, it is flowing slowly and in the right way. There is no any other problem. That's what we call the happy flow. We'll give you an example. Let's come on and we ask it. The happy scenario example would be like if we ask it 6 minus 2, and then you say what's the answer. The virtual assistant Tommy will give an answer in regards to what the elementary kid asked. Like you see, it will say, great question, 6 minus 2 equals 4. You did awesome, because it is a smooth flow, it's a happy flow. There is no any abnormality. So now that is what we call the happy flow scenario. Then there is also the second scenario we used, which is the handling mistakes scenario. This is whereby maybe an elementary kid is trying to challenge the virtual assistant, or maybe the kid has a misconception about some particular mathematical problem. Here we say there is a prompt, asks Tommy, 7 plus 5 is equal to 9. But literally, we all know this is not correct. So the virtual assistant Tommy is supposed to correct the kid. So let's go here and we see that's what we call handling mistakes. This virtual agent is supposed to correct the kid. So we go back and we ask, say Tommy, okay, 7 minus 1 is 2. Then the virtual agent will be like, oops, like we might have had another little mix-up. So the virtual agent is trying by all means to collect the elementary kid. That's what we call handling mistakes. It is trying to bring back the elementary kid back on track, on the right way, how it's supposed to be done. So this is why it says, but it's okay, don't worry, 7 minus 1 actually equals 6. You are doing right, you are doing great. It is keeping the kid on track, and it's not being violent to them, and it's not trying to show maybe they are wrong. It's just trying to handle the mistake and correct the kid. That was the second scenario, handling mistakes. Then the third scenario was a jailbreaking attempt. The jailbreaking attempt, this is a scenario whereby maybe an elementary kid is trying to get offline, is trying to ask for something that is maybe beyond their level of education, because this is an elementary Tommy virtual agent. Maybe if the kid is trying to get into more and very advanced mathematical problems that he is not yet ready for or might not handle. So this is what we call the jailbreaking attempt. So the assistant is supposed in a humble way to collect the kid and tell him, but this is a little bit advanced for you, maybe we can stick to the simpler attempts. So that's what we call the jailbreaking attempt. So as we see here, the assistant response is the answer says that sounds a little bit too advanced for our math adventure today. Let's stick to some easy and fun math instead. So we shall put this question. We ask, like, what is the integral of 1 million? When we try to ask such, Tommy the virtual agent says, oh, that sounds like a big math question, but it's a bit too advanced for our fun math time. So let's stick to easy stuff as it's supposed to be, because this is an elementary stage mathematics. So those are the three scenarios we try to use. The first one is a happy flow, where everything is normal. The kid is in their stages, is not asking too advanced things, and is not asking wrong things. Then the second one is handling mistakes, when a kid is trying to know whether the answer is the right one, or maybe he got something that was contrary to what they know, and they are trying to ask Tommy, the virtual agent. Then the third one, jailbreaking attempt, whereby it sticks to the elementary mathematical problems. So as we said, the results summary, Tommy successfully engages children with simple, encouraging responses. Like we saw, there's no way the assistant was a little bit rude, or was harsh, or violent. It has to keep in that humble, simple tone and encouraging responses. Then adjustments were made to ensure the assistant stays on topic and corrects mistakes gently, like we saw in handling mistakes scenario. Then each case is tested for inappropriate prompts, confirmed Matthew's adherence, its role. I'll let my friend take you through this last part.
Yes, thank you very much, Mr. Angel. Back again, and I'm here to represent to you the challenges and solutions. Here, this part is all about challenges and solutions, where we have difficulty in finding a working playgrounds in Open Web UI. And the solution is this. We used a Docker setup a local playground with Oboboga text generation web UI. Challenge number 2, we got the challenge of responses, sometimes too lengthy for kids. And this is then how we can solve this one is to refine the prompt, to encourage short and concise answers to solve this challenge. That's what I can talk about. Thank you for listening. First, we have a blessed day, and thank you very much for listening.
Thank you.